going to work through a problem involving straight line graphs today. So a kind of classic multi-step problem. We've got to work out all the things that we need to do and find out to get to an answer. So we've got 2 points, A and B. So A is 1, 8, B is minus 3, 2. We have a line L1 which passes through A and B, so we can kind of already start thinking about stuff we might want to do with that. L2 is perpendicular to L1 and passes through the point A, so we already might have ideas about what we're going to do with that. L1 and L2 cross the x-axis at points C and D. We want to try and find the area of triangle ACD. So with this sort of question, when there's a lot going on, I would always want to draw some sort of diagram to refer to, because otherwise it's just going to get really, really confusing. So it doesn't have to be perfect, but if you make it believable, it at least helps then so that your answers sort of make sense. So if I go and put on my diagram point A, 1, 8, so I'm going to put that somewhere believable as a point A, so that's my 1, 8. I can write on over here. Minus 3, 2, so if I put that somewhere around here, then that kind of looks believable as to where that point might be. If I then keep reading, I've then got L1 that passes through both of those, so I might draw L1 on my diagram. So L1 goes something like that, trying to make sure I hit those points. I then have L2, which is perpendicular to that line and passes through point A. So now I'm going to do a 90-degree switch and put it down there. And then my L1 and L2 cross the x-axis at points C and D. So it doesn't say which one's which. It might normally say something like respectively here, which means that the C would belong to L1 and the D would belong to L2. So this was our L1, so we'll call this one C. And then this was our L2, so we'll call this one D. And our aim is to find the area of triangle ACD. So we can now see what we're trying to do on our diagram. So now we can start thinking about what we need to work out. Okay? So ultimately, to answer this question, if I said, what's the area of this triangle, I really want to know what this base length here would be. I already know the height, because I've got my point A up here, and I have my y coordinate for that. So I already know the height is 8. So what I'm missing is this length here. Now to work that out, I need to know what points C and D are. So you go, right, okay, so if I need to know what these 2 points, C and D, would be, how am I going to do that? Well, I know they're on the x-axis. So if they're on the x-axis, I know that y is 0. And then what would I need to know? I need to know the equations of these lines. So we now have something that we can work with and start trying to find out. So if we start with L1, which passes through points A and B. So L1, we know we need a gradient first of all, because we want the equation of a straight line. So if I do my gradient, 2 minus 8 over minus 3 minus 1. So I get minus 6 over minus 4, simplify that and call it 3 over 2. So I now have a gradient for L1. Once I have a gradient, I have enough to go through and find out the equation because I also have a point in this case. So I've got y, I'm going to use point A. Remember, you can use point B as well. It shouldn't make any difference. So y minus 8 equals 3 over 2 x minus 1. Now I'm going to leave it like that for now. Obviously, we could expand it, rearrange it, put it in a different form, but I'm just going to leave it like that because I'll have a think about what I want to do with it and the best option after. So I can then do L2. So L2, we know is perpendicular to L1. So remember, we already have the gradient for L1, so our perpendicular gradient is going to be the negative reciprocal of that one, so minus 2 over 3. And we know this time it definitely passes through point A, so we don't have a choice. We have to use this one because it's point A that we need to sub in. So we've got y minus 8 equals minus 2/3 x minus 1. So we now have the 2 equations for our lines. We have L1, we have L2. So we know on our diagram up here, that's the L1. We have an equation. That's L2. We have an equation. We want to find out points C and D. So we already identified that at both of those points here, we know y would equal 0. So we can use our equations to find out what those values would be. Okay? So if I come down here and say, let's y equals 0 for that, we get minus 8 equals 3 over 2 x minus 1. Just solving that in a kind of nice simple way. So we get minus 16 over 3. And then with plus 1. So I'm solving quite a few bits in one step. Obviously, it's up to you how many lines of working you want to show. That would then get me minus 13 over 3. Which on my diagram kind of makes sense, right? Remember, that's the point. It's not that it's perfect, but it's believable. So minus 13 over 3. Yeah, it's definitely on the left side of the y-axis. So we know it's negative. Kind of sort of looks like it sits in the right place. So we go, okay, fine. We can mark that on our diagram over here. Minus 13 over 3, 0. So we know that point. We repeat the same thing for L2, so we'd like to know where point D is. So if we go through and do the same idea, so when y equals 0, we get minus 8 equals minus 2/3 x minus 1. So again, minuses are going to cancel out, so I get rid of those. Times by 3, divide by 2, so I get 24 over 2 or 12, and then I add 1. This one works out as a nice whole number. Just get x equals 13. So I'm going to put that on my diagram. So I've got 13, 0 as well. So now I have everything I'd want to know to try and work out the area. I just need to do it. So 13 over here minus 13 over 3, the length of that line CD. Okay, so let's do it underneath our diagram over here. So length of CD would be 13 minus minus or plus 13 over 3. So we've got 13 minus 13 over 3. Which gets us 39 over 3 plus 13 over 3 or 52 over 3 as our base, right? So that's going to be the base of our triangle. So therefore the area of our triangle is going to be a half times that base of 52 over 3 and then times our height, which remember is just this vertical height here, which is our y coordinate of A. So we're going to times that by 8. So the half and the 8 gets us 4, and then we times that by 52 over 3, we just get 208 over 3, which doesn't simplify at all, but there's our answer. All right, so pretty standard, right? Not saying that it's super difficult, but lots and lots of steps along the way, so we have to make sure we understand how to do each of those bits on their own. So find the equation by doing the gradient and our point. Once we have that, we can find our perpendicular. Once we have that, we can find out where they cross the x-axis. Once we have that, we can find out our area. Let me know in the comments if this is the sort of question that sometimes causes you a bit of trouble, because you'll sometimes get a bit lost along the way of what you're trying to work out. Hit that like button and subscribe for more help with your A-level maths.